All right, so we're into chapter 10 right now, and we're going to be covering apportionment, and we're going to talk about Alexander Hamilton's method of apportionment and how it caused something called the Alabama paradox. And then we're also going to calculate absolute and relative unfairness. Okay, so there's the man, Alexander Hamilton, and he came up with this method of apportioning the first U.S. Congress. And it was used for a while, but they ran into a problem because in 1881, when they were using his method, Alabama was actually entitled to 8 representatives in the House that had 299 members. However, when the members went from 299 up to 300, Alabama actually lost one of their representatives in the House. And this became known as the Alabama paradox. So the way Hamilton did it was simple. He simply figured out, well, whatever percentage of a population they had, they would multiply that times they would divide that by the total population to figure out what percent the state had out of the whole population. So like if there was, I don't know, 50 million people in the United States and Alabama had like, I don't know, 150,000 people, you would take 150,000 and divide it by 50 million, just like we did in chapter 8. And that would give you a decimal answer. So if it was like 0.03, then they would only be entitled to 3% of the seats in the House of Representatives. So that's what he did. And that's step number 1. And this says Hamilton method applied to a consortium board, which it's like you can do this apportionment with anything. You can do it with the House of Representatives. You can do it with people sitting on a board. You can do it if you're running a fair in your school and you have to figure out how many booths you should give to each company that wants a booth or a table. I mean, it's just how you want to divide things up. So he would figure out that percentage and then multiply it times the size of whatever it is you're apportioning. And then whatever the whole number is, so if you divided and you did the percentage, you multiply it times the side of the board and you got like 3.75. Well, obviously 3 is the whole number. So you're going to get 3 seats. And then if the number of seats adds up okay, then you're done. If it doesn't, then you have to go on to step 3, which then will look at the 0.75 part. And they'll figure out, okay, whoever has the biggest fractional piece would get the next seat that's available. So let's look at an example to explain this better. All right, we got 3 companies. They have formed a consortium. They're going to have a 9-member board, okay? A 9-member board. That is what you're apportioning. And it says, with at least one executive on the board from each of the 3 companies, additional board members will be assigned in proportion to the number of stockholders in the company. So you've got 3 companies and they have these number of stockholders. So what they do is they add that up. And when you total up the number of stockholders, there's 10,000. So to get the percentage, you would simply, and the next slide shows a table here, they're taking the, for Naxon, there's the 4,700 that they had, divided by 10,000, and you get 0.47, which is 47%. But you will simply take that 47% and multiply it times 9. And that will give you 4.23. So Naxon is going to get 4 seats on the board. And then they do Erico. Erico has 3,700 stockholders out of the 10,000. And they're going to get 0.37. That's 37%. But just take 0.37 times 9. And they're going to get 3 whole seats on the board. And then you've got urobile, which is 1600 divided by 10,000. Need another color. And they're going to have 16%. So take 0.16 times 9. And when they do that, they're going to get 1 whole seat. Now, when you add the 4 and the 3 and the 1, that only adds up to 8 holes. It's supposed to be 9 whole seats, which means there's 1 more seat. And so what they do at this point is they're like, okay, well, let's compare all the fractional parts. There's a 0.23, a 0.33, and a 0.44. Of those 3 fractional parts, 0.44 is the biggest. So they're going to add 1 more seat to urobile. And they try to show this in the next slide. There it is. So I'm actually only going to be showing you this. I'm not going to be making these tables. I'm just going to show you the math, show you the whole numbers. It only added up to 8, and then the 0.44 was the biggest. So the Naxum still got 4, Erico got 3, but now urobile gets 2, and that does add up to 9. So we have apportioned them the way Hamilton would do it. And that's the Hamilton method.